Hello, hello. So we're going to continue on operations with complex numbers. Last lesson, we did adding and subtracting complex numbers. Today, we're going to learn how to multiply and divide these complex numbers, okay? Now, I'm only going to do one example on multiplication because when we actually do the division of the complex numbers, we're going to be doing a lot of multiplication, and you'll see that in the examples. Okay, so here's our first example. So when multiplying complex numbers, we use the distributive property and then we simplify. Simplify means we're going to add our like terms. Okay, so here you can use a distributive property. So we're going to multiply like this, or you can do FOIL, which means the first numbers, the outer numbers, the inner numbers, and the last numbers. Okay. All right, so here we go. Let's use the distributor property. So we have here 3 times 5, which is 15. Then we have 3 times a positive 7i, so that is a positive 21i. Okay, then we have a negative 8i times 5 gives us a negative 40i. And then lastly, we have negative 8i times positive 7i, which gives us a negative 56i squared. Okay, so we have to also recall that I squared is equal to negative 1. So I can actually rewrite this as 15 plus 21i minus 40i. And then I have minus 56 times the negative 1. Okay, so this just ends up being a positive 56. Right, we're going to combine our like terms. So I'm going to add our constants together. Okay, so here we get 15 plus 56 gives us a 71. And then we add our imaginary parts together, our imaginary numbers here. Okay, so then we have positive 21 minus 40, which gives us a negative 19i. Okay, and when we write our complex numbers, we write in a plus bi form. All right. Okay, so one important aspect in dividing complex numbers is finding the complex conjugate. Okay, and what that means is, or why we do that is because we want to kind of eliminate our middle term or I term, because we're going to rationalize that denominator. So we have to make sure that we don't have that I term in the denominator. So to do the conjugate, all we do is change this to the opposite sign. So here the conjugate is 2 minus 3i. Okay, the first number, the sign does not change. It's only this middle signage here. So here we have 3 minus 11i. Okay, this would be negative 5 minus 17i is the conjugate. Here we have 15 plus 31i. Okay, and lastly, it's negative 16 plus 17i. Okay, so you're going to see when we start dividing our complex numbers and we have to multiply by the conjugate, you're going to see why we end up using the conjugate. It ends up eliminating our I term. Okay, and then that allows us to rationalize that denominator. Okay, so here are the steps. I kind of try to make them as small or as simple as possible, the steps. I didn't want to do multi-steps. So first, when we divide complex numbers, we multiply by the conjugate of the denominator, both on the denominator and the numerator. Okay, and then we just multiply and then simplify, right? So here's our first example. So I had a good question in class, like, are these two separate problems? No, this is the problem, and then I just put in the conjugate. So the conjugate, and remember, we're only multiplying with the conjugate of the denominator because we're trying to rationalize that denominator. Okay, so the conjugate of 3 minus 5i is 3 plus 5i, but if I multiply the denominator, I also have to multiply that numerator. All right, so now this is the fun part. First, I am going to multiply the numerator. Okay, and we just multiply straight across using the distributive property. So you can distribute like this if you like. Okay, this method, I'm going to do it, I call it the box method. I know there's another term for it, I just can't remember it. So here I'm going to put 7, and this is a positive 2i. And here I'm going to multiply with 3, and then a positive 5i. So, and this works very much like a multiplication chart. Okay, so we're going to multiply 7 and 3, which is 21. Here we have 2i times 3, 6i. Here we have 7 times a positive 5i, which gives us a 35i. And then here we have 10i squared. Okay, and we have to remember that I squared is equal to -1. So this is the same as 10 times -1, which gives us a -10. So I'm going to put a little box around that. Okay, and if I notice here, my diagonals are like terms. So here we have, I'm going to add 21 and -10 together. So that gives me 11. And then I am going to add our imaginary parts together. So we're just combining like terms now. And then 35i plus 6i gives us a positive 41i. Okay, so here I have 11 plus 41i. And now I'm going to do the same thing. Now I have to multiply my denominator. So now I'm going to multiply these two together. So I'm going to do the same thing. If you want to use whatever method, distributive, FOIL, however. Okay, here just for me, I like to have it nice and neat. Okay, so then 3 minus 5i, and then 3 and a positive 5i. Okay, so here I get 9, multiply those two, I get -15i. Now notice here I get a positive 15i, so these two cancel out. So that's exactly why we did the conjugate. Okay, and then here I get -25i squared, but I squared is -1. So -1 times -25 is a positive 25. So you could think of it as, oh, it just changed, the I squared changes the sign. Someone mentioned that, and I said, yeah, I guess you're right. Okay, so now I add my like term. So I have 9 plus 25, which gives me 34. And then I have to write it in a plus bi form, which is 11 over 34 plus 41 over 34i. That's an a plus bi form. All right, very good. So now let's try this next one. So we only have 2 more examples. So first I say I have to multiply top and bottom by the conjugate of the denominator. So the conjugate is 4 plus i. So I got to do 4 plus i. See how I mentioned we have to do a lot of, even though we're dividing, we're doing a lot of multiplication. So here we go. I'm going to prepare my first one. So here's 1 plus 4i, and then 4 plus i. So then I multiply, here I get a 4. Here 4i plus 4 is 16i. 1 times I is I. And then here I have 4i squared. So that gives me a -4. Okay, 4 and a -4 gives me a 0. I can actually write that 0, okay? And then here I add these two, so then it's a positive 17i. So here I have a 17i. Right, next I'm going to multiply the denominators, or the two terms in the denominator. Here I have 4 minus I, 4 and a positive I. So here I have 16. This is a -4i, positive 4i, and that's exactly what I expected because That's the reason why we multiplied by the conjugate, because we got rid of the I term. Okay, and then I have negative I squared, which just is the same as negative 1I squared. I squared, once again, is equal to negative 1. So this is the same as negative 1 times negative 1, which gives me just 1, a positive 1. Okay, I add my two constants together, like combining like terms, and I get 17. Okay. Then the 17 divides out, so then I just get I. And if I need it in A plus BI form, then this would be 0 plus I. All right, almost done. One more to go. So go ahead and pause this, give it a try, see what you get. Remember, it's just trying, and then come back and unpause and see if you get what I get, okay? Okay, so first I'm going to be multiplying by the conjugate, both top and bottom. All right, so now I have to multiply the two terms in my numerator, which is 2 minus 3i and 5 and a negative 8i. Okay, so here I get 10 minus 15i minus 16i, and then 24i squared, which is negative 24 here. Okay, I combine my like terms here. 10 minus 24 is negative 14. Negative 16i plus a negative 15i gives me a negative 31i. That is in my numerator. Okay, so the next one, I have 5 positive 8i, and then 5 and negative 8i. 25, 40i, negative 40i, and then negative 64i squared, which gives me a positive 64. Okay, these two cancel. Then I have an 89. Okay, I still have to write this in A plus BI form. So I have negative 14 over 89 minus 31 over 89i. All right, yeah, lots of multiplying and the dividing. All right, so here we go. You have a delta math assignment, okay? And the delta math assignment is multiply and divide complex numbers. You'll just have like maybe 1 or 2 multiplication and maybe like 2 or 3 division, dividing complex number problems to work on, okay? And if you have any questions, make sure to send me a Schoology message, okay? Bye.